You go to why the benefits of concentrates, in addition to being easier to transport, it's actually preferred by cannabis connoisseurs as well. So you're not here to listen to stats, you're here to listen to Murphy Murri and educate. So without further ado,
yeah, thank you for coming, you guys. Unfortunately, I do actually have more stats for you. You're not getting out of any of that. My name is Murphy. I've been working in the legal cannabis industry since 2009. I got my start in Colorado. And I love coming to new states with new legalization because it is a little bit of Groundhog Day every time. Because unfortunately, while we all say things like we're gonna learn from the mistakes of the other states, and we're going to improve upon the programs that they developed, we all still tend to stumble and fall into these same types of human patterns that we always have. And so whatever struggles you're dealing with today, please know that they are insignificant to the struggles you will deal with tomorrow. It is coming for you. And so for those of you who have followed me and know what I've been doing in the industry for a while, you're probably used to hearing me talk about equipment, because after a decade of working in this industry, I no longer want to do work in this industry, and I want my equipment to do that work for me because I am tired. So I tend to really talk about things from the equipment angle, but today I'm going to talk to you guys about the importance of the quality of your method and your solvent, which is something I don't get into as often because it's usually a decision you've already made by the time I'm talking to you about your equipment. The methods that we choose in the cannabis industry are another really good example of the way that we tend to repeat our own mistakes over and over. Chemistry and science in general is, a pursuit of failure over and over and over again. We're constantly trying to figure out if we were wrong, while also believing very strongly that we are right, which is a difficult way to live, but I think that is quintessentially cannabis business as well. And so in that way, I really want to help bridge the gap between what we've kind of always done with cannabis versus what we have to do going forward. Because as you guys just heard, the future is going to be concentrates, and there's a couple of important reasons for that. The most striking one is that the things that cannabis, raw flower, struggles with from the testing and compliance perspective, concentrates can overcome with ease. And so for that reason alone, science is going to win this fight against government compliance because we have more control in the lab than we've ever had before. So in order to get into that, I'm going to talk to you guys a little bit about, I don't know. There we go. All right. So what's hash? I tend to use the word hash for everything when I'm talking about cannabis concentrates because the word hash is centuries and centuries and centuries old. And a lot of that etymology comes back from the Arabic regions. And this has always just meant the resin from the cannabis plant. And our means of collecting that resin have changed a little bit for the first few thousand years that we were doing stuff, and then a lot in the past couple of decades, which is a really important thing for you guys to keep in mind as we talk about what's going to happen next year and the year after that. Because these changes are not consistent or gradual. They are all at once, and there's some pretty important reasons for that. So, going backwards, hold on. Brief history. I'm sure you guys have heard about cannabis by now. Humans have been using it pretty much ever since we've existed. Most of our archaeological discoveries include cannabis seeds, cannabis fibers. This plant has been everywhere that we have been, and the way that we have used it has evolved over the years, but the way that we've understood that use has changed a lot and been largely dependent upon the written word, which is tricky. And now in the world of the internet, the written word means even less than it used to. In the way that a lot of history comes from a couple of rocks that were inscribed upon and then Bibles and other very human artifacts, we have a lot of information about cannabis that is kind of interpreted. And so it's a lot of spiritual and a lot of traditional and tribal sort of information that we've retained, but it has almost always led us back, by the time it gets back to Rome or back to Greece, to this idea that humans have used cannabis for medicinal reasons, for industrial reasons, for spiritual reasons. Humans are using cannabis, and we've done it forever and ever, which is great news for us because that has implied a pretty significant level of safety in using cannabis. But it hasn't, we didn't have ice until like yesterday in the scope of history, you guys. That part is very new to us. And so just having electricity in our homes, just having electricity for scientific research, and some of the ways that we, again, document and write things down has changed dramatically. And that access to technology has created this conflict between the traditional markets, which have always existed in spite of whatever else mankind was going towards. What was once hash, just the sticky stuff rubbed off of the cannabis plant, is now, a whole other product of hash. And so it's not until the 21st century that we actually have our first cannabis deaths ever. And it's something that all of our opposition was waiting for. And it's something that all of us have spent most of our political lives advocating on the platform of. I gotta ask you guys and beg you guys to stop doing that. We have no reason to believe that cannabis is safe. We just don't have any evidence of its danger yet. Science tells us that every year we discover new cannabinoids. Every year we discover worse ways to manufacture and process them and more unsafe ways to manufacture and process them. And we tend to discover those just as fast as we discover better ways. And so the people who are growing cannabinoids out of enzymes in sterile environments are not in the same realm as the people who are making fake dabs in their garage that are diluting it with weird hash that they got somewhere. And the grandmother who's just trying to figure out how to make her own cookies has no idea how to tell the difference between these two extremes, because cannabis and hash have always been perceived as this kind of delicate thing that we can trust, because why would Mother Earth grow something that could hurt us, right? Keep in mind, most of these organic toxins are absolutely organic and grown by Mother Earth, and when we're dealing with cannabis now, hash is what we make it. And so it is no longer something that we can put on the responsibility of the grower. And that's the platform that I think we all have to stand on now. It's not that cannabis is safe, but that the self-policing and internal quality standards that we set for ourselves inspire safety and call for safety, because we will be wrong about what's safe today, and we might find out as the result of people dying, because that's generally how we get enough attention for these issues. And so when we're talking about hash today, the decisions that you make about how to manufacture and process it, especially from a business perspective, are not about what is natural, and they're not about what is organic, and they're not about these very feel-good ideas about the cannabis. It's 100% about your accountability for the product that you produce, which you can only provide if you have a good understanding of your method, if you have a good understanding of your process, if you have a good risk analysis, not for whether or not you can sell 5,000 pens a month, but whether or not selling 5,000 pens a month will kill one of those 33 people. You've got to take those concerns into consideration, and it's something that the cannabis industry is threatened most by, is that we do have a significant divide between the people who embrace the scientific research and the people who use solvents, and the people who don't, and the people who want to use cannabis as it is. But we don't have any reason to believe any of those things are safe. Even the plants that we're growing inside of a building are being manipulated by us in every possible way. And so for that reason, you have to make good choices about what you're going to extract it and what you want to make out of that. Think about whether you are the business owner or the employee or the consumer, because whichever role you play, it's important to you. So there's a lot of ways to extract these nonpolar compounds, and some of them have really, really, really high risks, and so they're easy to avoid. Some of them are very, very expensive, so they're easy to avoid. Some of them don't produce a product that is competitive to sell, so they're easy to avoid. A lot of them are the perfect process for a specific product, and almost none of us have a business model that's actually that solid yet, and so we all have to be adaptable. And each of these processes that I put on the board here are really significantly different from each other, which is why I'm going to touch on them a little bit. There's a lot of other solvents we can use, and again, we can grow cannabinoids in a lot of different ways other than growing them out of cannabis now. So the future of cannabis, I think, really for all of us, is going to be about identifying what, besides the cannabinoids that we're extracting from each of these different methods, is valuable. And we do not know that today. We all have pretty good guesses that are almost never measured. And so moving forward, how you make this decision, we're just going to assume that all of these are going to give us the cannabinoids we want because they can. And then, what else do you want to do with it? What else do you need from it? What does your input material give you to work with in order to improve upon that? So, from those extraction methods, you also have purification methods. And a lot of times it's easy to confuse those two. For example, a lot of people will refer to distillate, the noun, which is just distilled oil, which means simply oil that has been evaporated into a vapor and then recondensed into a liquid over here. There can be filtration and separation in between those two activities, but that's not guaranteed. We're just saying that it definitely works at the same time. Very similar to the garden. All the hard work that you do, all of the contaminants that carried with it are now left behind. You've polluted your product rather than purified it in that way, because what we want to be able to say is that any contaminants that are in that product are naturally occurring and that we didn't know about them, and everything we know about we remove, and anything that we introduce we remove so we could be accountable. When it comes to these ice water extractions, it's really hard to be accountable if you don't control 100% of that process. And chemical solvent extraction, because we're both washing pesticides down the drain. We're both washing heavy metals down the drain. We're both increasing the ratio of contaminants to what it was when we got it to what it is now. And the only way you'll know if you're not contributing to that is if you measure it. And so you've got to have measurements on your water. You've got to have measurements on your ice. You've got to have measurements on your equipment. And sanitary equipment is really important. It took Colorado like 8.5 years to finally ban the plastic dorm washers for bubble hash making, when everyone has always known since the very first forums on Weed Tracker that those grow mold in the hose and nobody cleans them. And so, it takes a long time for regulations to catch up, but the internet doesn't forget, and I am here to personally shame you into doing a better job with sanitation if that's what it takes. Because you can only be accountable for this process if you're accountable for all of that equipment. So even in a solventless environment, stainless steel tables, hand washing sinks, gloves everywhere, literally just having a 3-compartment sink and knowing how to properly use soap and water. I watch this industry clean everything with isopropyl like they've never heard of soap. Soap and water, you guys, it rules. It cleans everything. And you actually have to use it to clean off the isopropyl that you just sprayed all over your now flammable lab. So take care of your extraction environment even with ice water and rosin, you guys. Next up, supercritical CO2, subcritical CO2, whatever kind of CO2 that you want to use, if I'm being honest. The key difference here is that we're not talking about dry ice. We're talking about creating a scenario where that gaseous CO2 is converted into a liquid. This is one of the most widespread botanical extraction methods because it's the most flexible solvent. CO2 has a very controllable solvency based on controlling the temperature and pressure at the same time. And that is a lot of fun from a scientific perspective. It gives you a lot of opportunity to do weird stuff and a lot of responsibility to repeat your process and do it the same way every time if you want a repeatable output. Unfortunately, we don't get a repeatable output because of the variability of cannabis. And so a lot of CO2 products, I literally saw people wince when that slide came up. A lot of CO2 products get a bad rap because they're extracted poorly. And a lot of that comes from poor process and also this automation issue. Automation only works if your process is good. Your process is only good if you tested it and measured it against the equipment that you're using, the environment you're using it in, the material you're using it with, and every single employee you have ever trained to touch it. And so if you are not testing vacuum after you change the oil in your vacuum pump, you have no reason to believe it is capable of deeper vacuum now. You have to check. And a lot of CO2 suffers from that automation because it's not checked by a human person. But if it is, and that person is competent, you can do really exciting things with CO2, specifically in the realm of terpenes. And that's in part because since we can control that solvency with CO2, we can capture terpenes that we don't get from our other terpene-heavy solvent extractions, because some of those terpenes are just a little bit too polar for our traditional organic solvents. CO2 can capture those for us, and that makes it also a really good candidate to capture a lot of the contaminants that we need to be studying, because those are the things that are in all of our products that make up mass that we don't identify or know what it is. So CO2 is popular for getting a lot of lipids and a lot of waxes, but lipids and waxes are big business, you guys, and a lot of those waste products can absolutely be monetized. CO2 is a great candidate for a lot of processes, many of them downstream in my opinion, as well as right up front stream. I think one of the biggest disadvantages is that you can't deal with fresh frozen material when you're dealing with CO2. You have to deal with dry material in order to keep things safe. There's a few systems that give you enough control to maybe mitigate that, but it would not be the first system that I would recommend to anyone up front. If you're not prepared to build your own CO2 system, you probably want to stay away from putting water in it. The other thing you have to deal with is that it is still dangerous. A lot of people think about skipping the flammability as making it safer, but the ASME pressure vessel code wasn't written based on combustibility. It was written based on steam, you guys. We lost entire apartment buildings to boiler explosions, and that's why we started regulating pressure. So combustibility is scary, but it's not the scariest. Oh, there's someone behind me. I said news. Because the worst place for you to be is in the room with that equipment when it's running. You want that to be as automated as possible, but that's not often what we see with butane and propane because the initial infrastructure bill is so high. That being said, you can deal with fresh frozen material, butane and propane, and that is the biggest shortcut to money that cannabis has ever known, because you can skip all of your drying, all of your curing, all of your trimming, and all that space and all that time and get paid the day of harvest. Something like CO2 can now be accessed with something like butane and propane due to their very, very compatible solvency and also that very low temperature recovery process. And because it is all enclosed in that C1D1 space, it is a relatively small footprint. In most of these businesses, it is just a very high energy demand. So while we're not necessarily dealing with mechanical pumps, we are dealing with a lot of exhaust and a lot of fans. And so it's kind of like thinking about how cheap weed is to grow and how expensive a garden is to build. Running butane and propane is really cheap. Building it out can cost quite a bit. That being said, you get a crude oil out of butane and propane that is higher than the purified version of most of these other final products. And so there's huge advantages to butane and propane. But of course, it can explode. It's worse than being flammable. It's worse than just pressure. It's all the bad things at once. It's harder to respond to. The equipment is more expensive to get it to actually be certifiable at these temperatures and pressures, which is something that's, again, really important anytime I'm coming into a new state. I cannot tell you guys how many times I have seen pressure safety inspectors post a picture of the outside of my very first lab in their "do not do this" safety presentation, because I followed them around at expos for 10 years, watching them demonstrate that my chained up tanks on my chain link fence wasn't good enough. I was doing my best at the time. Your best at this time can be better. And all of us are saying that from a position of having done worse ourselves. When it comes to a lot of this, build out and equipment, it is worth your time and money to buy it once. And so buy the high quality pieces, because in the same way that you will not necessarily have to replace them, they will also hold a higher resale value than something that has no UL listing, because you might be able to unload a 5-liter roto right now, no problem, but as soon as that UL listing is required by every municipality, now you're gonna have a 5-liter roto that is worth no money to anyone. And so obviously go sell all of your 5-liter rotos that you don't need today, but also plan forward on buying the most expensive, most compliant version of whatever part you need, and assume that you'll need 2 of them, and then assume that you'll need another one 6 months from now, and build that maintenance and that quality into your infrastructure, because the high pressure equipment is going to be the most heavily regulated, and it's going to be heavily regulated not because it's so easy to fail, but because so many people take advantage of the shortcuts, and of course you fail when your equipment isn't safe. I can't even blame you, except that I am, because I'm telling you right now that you could buy safer equipment and all the rest of us could have less engineers charging us $5,000 a day just to come out and look. So build it properly the first time, invest in that infrastructure straight up. While we're talking about infrastructure, ethanol extraction is going to be the last one that I've blabbed to you guys about today. Ethanol extraction is another industrial standard, and it is industrial in the food industry. Whereas we see CO2 in things like botanicals like perfume and fragrances and even pharmaceuticals, ethanol is very much in the bulk extraction world. So we see a lot of ethanol extraction in waste product refinement. We see a lot of ethanol extraction in food flavorings, and we see a lot of ethanol extraction in products that are not purchased based on a bill of health. So think about like candy flavorings. Think about food colorings, things that are in your food products that are then FDA approved, but that are not like a carrot. It's supposed to have some value to you, or like a bread that's supposed to have a certain amount of enriched grains based on what it claimed on the label. A lot of the products that are being extracted with ethanol are regulated products, but not necessarily in the stream of what you would be consuming on a day-to-day basis. Again, think about just alcohol in general. Cigarettes are highly regulated, it does not make them safe. And a lot of ethanol products are feeding into the markets that are the least regulated right now. And this comes from a low barrier to entry with that upfront cost. Not because it's actually cheap to build out an ethanol facility, but because the equipment up front is not pressurized. And so you can buy cheaper equipment and get away with it for longer. But your solvent compatibility is really important to consider here. And when I bring up solvent compatibility, I'm not just talking about the ethanol, I'm actually really talking about the water that's going to be in your ethanol, because these lower quality pieces of equipment are going to rust. They're going to fall apart. A lot of these plastics are going to break down when you're using cheap equipment with ethanol. That's my timer, you guys. I'm so close. Okay, now we got to talk fast. So, oh my gosh. It's my Oscar music. So, even though we're at low pressure, we do have a lot of potential solvent incompatibility with the equipment, which is very easily overlooked with ethanol, because in addition to the solvent, the water in that solvent, you also have to think back about the oil that you're using. And so a lot of times people opt for an ethanol product because they can use aluminum, but that aluminum is still not compatible with your terpenes that are in your oil that is in that ethanol. And so it's still not compatible with your process. You still need stainless steel. And so there's a lot of cheap, large-scale ethanol extraction happening. And one of the things that you see people investing in the most is that solvent recovery. In part because they got to get that solvent out of the way so that they can distill it, but also in part because that ethanol is expensive. I want you guys to all know that if you have a business, you can submit forms, you get that tax money written off. You don't have to just eat that every day. So get an accountant who takes care of you properly, because you should know that. But also, if your ethanol hasn't been perfectly recycled and you haven't tested it for purity, which is super easy because you can go and get purity test kits for ethanol at any home brew store, you don't know that you have 99% pure ethanol going back in. And in the same way that all that water can get real gross with that bubble hash we talked about earlier, all the water that ends up in your ethanol extract is super gross, because it's going to have the pesticides, heavy metals, and weird foliar sprays, and dirt and clay from the field, and whatever caterpillar bodies, all of the stuff that was on that product. But it's also going to have that azeotropic relationship with the ethanol. So now you're going to have stuff that's dissolved in this watery ethanol that isn't soluble in anything else, which makes it really hard to clean. And if it's hard to clean, you guys aren't going to do it. And if you don't clean it, it gets really gross. So keeping your ethanol clean is one of the biggest struggles of ethanol recovery, and it's the one that nobody talks about. Everyone wants to know gallons per hour. I want to know percentages per liter. How clean is what I got out? Do I have to do it again? Or am I done? And is it fast enough that I can afford to do it again? These are the kinds of questions that are often not asked until 2 years from now. You look at your books and you say, I have spent $750,000 on ethanol, and I have to place an order for ethanol right now. Something must be wrong. You know, you've got to start looking at these issues today, and a lot of it comes from really knowing your process, which is hard to do when you don't know your product. So in the same way that I call everything hash, I want you guys to know that all of those extraction methods are just to make crude oil. And we all think of something brown and gross and weird when we think of crude oil, but if you haven't taken it to an additional purification step, something like that crystallization, distillation, you know, additional refinement and filtration, it's still crude oil. It just might be really great crude oil. And in that regard, all of these final products can come from those same original extraction methods. So a lot of the issues that you run into with dirty ethanol, or you know, downtime in a CO2 system, or you know, the flammability with butane and propane, you can mitigate elsewhere in your process. A lot of people look at what they want to make and then have blinders on all the way through and don't think about how fast it needs to be from start to finish. In the same way that a lot of growers don't give themselves enough space to dry because they're so worried about how to buy their nutrients today. But you're going to ruin your weed in a few months if you build a wall for yourself to climb. All of your final products are possible with all of those initial extraction methods. The biggest question is what you want to make. And so if you want to deal with fresh frozen, you need butane and propane. If you want to deal with massive scale, you need something that is in an industrial area with the proper rating, and you need significant infrastructure. If you want something small scale that you can pop out in the front of your garden, you want low risk to the rest of your garden and the rest of your employees. And so every single one of these methods is valid because all of them can take you to distilled oil. All of them can take you to isolate. All of them can finish that chemical purity goal. You just have to figure out what the rest of it is all about. And so cannabinoid extraction is easy, you guys. We've been doing it for thousands of years, mostly with our bare hands and rocks and stuff. We've got the tools to do it better now, and we've got the tools to test it to make sure that it's better now. But we also have a whole lot of free will to make those choices. And so I hope that you guys will consider all these scary things that I said to you when you're smoking weed at your next opportunity. Because your product is only as good as the person who touched it. And when we're talking about hash, whether you actually made it with your hands or you put it in 17 different dirty extractors, you touched it. And so we've all got to be accountable for that. And the only way we can be accountable is to test it. There's two methods of testing we can deal with. The first one, we're great at, qualitative. That's just how it looks to us. That's all your shatter, that's all your crumble, that's all your butter and batter and all of these things that don't mean anything because we're not identifying the chemical contents of it. That's qualitative. That's the information I could have gotten myself when I looked at it. The other half that we have to care about is going to be the quantitative. And we don't have to care about it because we understand it yet. We have to care about it because we will never understand it if we don't start to pay attention. So on that note, I'm going to introduce you guys to Stephanie from High Precision Gas. She's the chemist over there. High Precision Gas has their own on-site analytical equipment. They test all of their solvents themselves. And Stephanie is going to talk to you guys a little bit about that product and process. If you guys have any questions for her, please don't hesitate to reach out to Sano Gardens, and I'll be there now. I've got a giveaway question. I need someone. All right, who can tell me when ice was brought to America, like in refrigerators? Who can look that up? One person can tell me when ice was brought to America and we can start making bubble hash. 1926?
1937.
37?
32.
It's whenever we got the railroad. 1836, there we go. All right.
Sounds right.
You guys are there? Oldest bubble hash, there we go. All right. So do one more? All right, one more. All right. I want someone else to shout out a good extraction solvent for cannabis that wasn't in this demonstration.
Pentane.
Pentane. All right. Love it.
Hi everyone, my name is Stephanie and I'm the Quality Control Manager at High Precision Gas, and today I'm going to be talking about the importance of using high purity solvents and what to look for when choosing one. To start off with, I'm just going to go a brief outline of what I'll be covering today. I decided to include it here. The next one is supercritical fluid, so clean extraction with supercritical CO2 as your solvent. The third one is using alcohol, so something like ethanol extraction, and I've included some images, and I know not everybody can see them, so it's kind of sad. And lastly, what I'll be focusing primarily on today are hydrocarbons as your solvent, and that's your butane, isobutane, and propane. So I'm going to start off by talking about hydrocarbons and going more into detail on what they are. So I'll be talking about the short chain hydrocarbons, which just means that they have 1 to 5 carbons in the compound, and again, just butane, isobutane, and propane I'll be focusing on. And these are gases at room temperature, but when you purchase a solvent, it'll be in a pressurized vessel in the liquid state. And these are often sought out by extractors due to their physical properties, one of them being how they're nonpolar, and you get to extract all your nonpolar compounds that you desire. And the other one, as Murphy mentioned, the low boiling point. So since they have a low boiling point, you don't have to process your extract with high temperatures, so you're not jeopardizing the integrity of your starting material and burning off heat sensitive like terpenes and the cannabinoids, so you get to process the low temperatures, which is really great. And now let's talk about solvent grades because they're not all made the same. So here I have HD10 and HD5, which is just commercial grade propane, and those are a minimum of 90 area. LPGs are more dense than air, so it will displace the air and it could lead to there is like things that you won't know, any contaminants. So now I'm going to talk about certificate of analysis, and this, I know not everybody can see these, but I have some chromatographs of our calibration gas, and it's just a separation of the compounds based on time. So the top one is for the heavier hydrocarbons, and you can see that they're coming out at a later time, and the lighter hydrocarbons are coming out at an earlier time because they're a lower boiling point. So we condense that information into a COA, and this is just a snapshot of one of our COAs that we provide. And what I wanted to highlight here was the difference between extraction grade and instrument grade, because they are both 99.5%, but I wanted you guys to see the difference. And the main difference is that we're testing an extraction grade for the heavier hydrocarbons, and those are really important because the B-tex compounds fall into that. And what are the B-tex compounds? So that's benzene, toluene, ethylbenzene, and xylenes. So these compounds, you should be worried about them because they're naturally occurring in liquefied petroleum products, and they're also regulated in the cannabis industry. So benzene in particular, that one is labeled by the EPA as a group A carcinogen, meaning it's known to cause cancer to humans, so you do not want that in your final product. Toluene and xylenes, those are group D, which means that there's not enough data to classify it as causing cancer, but there is data suggesting that it does damage the central nervous system. And once again, this is regulated by the cannabis industry, so this is just some specifications for California, but I know many states share the same specifications, and if they differ, it's only by a little bit. But you can see you have to have less than 1 ppm of benzene in your product because it is group A. So to end this short talk, it's purchase your solvent from a reliable source. Make sure you're not just like going to your local gas station or convenience store and purchasing like liquefied product from them. Lastly, second, request and inspect the COA. Ensure where you're getting your COA from. It's not a handoff from the sourcing plant because, as mentioned, they only test for the lighter hydrocarbons. They're not going to test anything with more than 6 carbons generally. Oh, and back to the COA. So generally when you get a COA, you want to see ND, which means it wasn't detected by the instruments. And at the very least, you want it to be below the specification, but ideally you want ND. And lastly, this matters because once again, the butex compounds are one of many compounds that are found in liquefied petroleum gases that are also regulated in the cannabis industry. So if you start off with a clean solvent, you're not introducing potential contamination to your product. And that's it. Thank you. Okay, so we're doing another giveaway. Okay, so giveaway question. Could somebody tell me the difference between extraction grade and instrument grade?
It's like they're going down with me, so like it's okay.
Yes.
95 and 99
What was that?
percentage. 95, 99%.
No.
Testing for
You
heavier
got it.
high.
We got one. What?
Testing for the heavy
Yes, yes, over there.
So the answer is it tests for butex compounds, which are harmful to the body. Either it could cause cancer or what is it? What else can it cause? What's good can butex compound? Oh, damage to the central nervous system. Right? So the same thing as you don't want propylene, which means plastic, in your solvents. Is you want to make sure, even though the 99.5% grade, you want to make sure they test for butex compound as well, which is different between instrumental grade and extraction grade.
Can I ask you a question? Yeah. So
Making it up.
me too. But we got it down.
She's an expert.
You test it yourselves, obviously, so you should be accountable for it. How often do you find those trace contaminants in product that is not supposed to happen or not supposed to have them from the supplier? Is that common? And what do you do when that happens?
So we actually have, we have tested some gas that has it. I guess it wasn't our gas, it was like, I guess, a return gas. But we have seen it in other companies' gases. But for us, we do have sulfur traps that will remove it if you find it. We haven't had to use them, but that is part of our process. So it's in line if it does happen.
Follow-up question.
Is it black?
I
don't know.
Would something like one of those sulfur traps be accessible and easy to use for people in this industry without gas right now?
Oh, definitely. You just have to have, it actually already comes in a cylinder and you just run your gas through it at like a certain flow. The question was, if you have like contaminated gas, can you easily get a sulfur trap and like purify your own gas, basically?
My answer is yes, so let's all cheer for that.
Right on.
Silver trap.
Thank you, High Precision Gas.
Yeah, one more question.
Yeah.
The sulfur trap, could you just run that in line constantly? And when you say naturally occurring, I mean, could they occur in your storage unit?
So, oh wait, no, do you want to say your
It said that they're naturally occurring. Can they occur in your storage tank or the tank you're using improperly stored? What causes that? And then can you run a sulfur trap as precaution in your line? And what's the consequences for doing that, like smaller yields?
So the liquefied petroleum gases, those come from like fossil fuels. So the butex compounds are naturally occurring in that process, like in the refining through like catalytic cracking and all that. So the processing plant should remove them, but there could be instances where they're not fully removed. And you wouldn't know that because the COA that they provide, it doesn't say like they don't test for that. So that's where they're naturally occurring. It's like when they're extracted. And then your second question for the sulfur trap. So that, you can't use it in line. We have one set aside. We don't use it in line because we run all our gases and qualify them before we sell them to customers. So obviously if we did detect something, we would run it through that. Yes?
So remove those contaminants, would it leave sulfur in the product?
Oh, okay. So the question was to remove those contaminants, would it leave sulfur in the product? So the company is actually called Sulfur Trap, but it is a molecular sieve.
That's beyond my understanding.
But if you're asking if sulfur in your gas can get into sulfur in your oil, yes, because the density of that oil reduces your distillation efficiency, and so then your gas doesn't separate very clean. And so it's literally just sulfur is heavy, but it's solid, and so if you don't distill it quickly enough, it won't stay with the gas, and so it should have to
This series of questions is one of the reasons I love this industry. So you guys hear about a process or something you can bolt on and it goes commercial. How do I build this into my system right now?
Yeah, honestly, I'm gonna have sulfur traps for sale. Anyway. I just buy that domain.
Awesome. Well, hey, thanks everyone for having us here tonight. High Precision Gas and the industry for coming out. My name is Sheldon Lotspeich, one of the co-founders of Carbon Chemistry. And really excited to be here because Oklahoma is a really unique frontier of the cannabis industry right now. And there's a lot of processors, we're seeing innovation, and it's just really exciting to see this part of the country just lighting up and just taking off and taking root. I'll try to be real quick, just give you guys a quick overview, introduction to us, and run through it. Carbon Chemistry has been around for coming up on 4 years. Started off in Colorado, and we were servicing the industry across the U.S. and some limited international supply too. My brother and I started the company because we saw a need, lack of supply, especially companies that are willing to work with this industry. And now we're starting to see more and more suppliers that are seeing the opportunity and taking a chance supporting the industry in the same way that operators are jumping in and seeing that there's greater opportunity than risk to supply for consumers that want to consume cannabis. Current affairs. Absorption has become, the comment about molecular sieve, what's that? An absorption process where you're holding back targeted compounds due to the pore characteristics of a filtered cartridge.
Okay, so sulfur stays there too?
I don't believe there's any free sulfur in the process.
Okay,
it's just bonding with those targeted compounds and then pulls them out of solution.
It does get saturated, so you just replace it.
And then that's also has to do with the flow rate in order to get that absorption. I'm not in the gas industry though. Just a quick rundown, Carbon Chemistry, we make particular products available for the industry, silicas, bentonite clays used for absorption and removing compounds in process. We do that by trying to make the goods available through getting it to front market, partnering with companies like High Precision Gas, who have customers and last mile delivery in order to help get our supplies to the people who are looking to use it. The reason we got into this is that we believe in helping people through supplies. You have to figure something out when you can't get stuff. And yeah. We're just getting into blends. So we haven't, it's all been pure, but that's actually stuff that we're exploring with some of our consultants that are here. And we get a lot of feedback on that. So we'd love to. We're increasing those capabilities. I'd love to get to more like mass drying, so that way we can make it so people don't have to dry the clays at their facility, and then also pre-blends. Love to explore more.
Expecting people to control their ambient.
Yeah, I know it's a lot. A couple things about Carbon Chemistry. The products, it's amazing. Go online and type in silica gel. That's what you want, right? There's tens of thousands of different types, from desiccant packets that are going to keep your stuff dry to different grain size, pore size, pH adjusted. It gets crazy. I mean, aerogels. These can be structural silica gels, manufacturing additives. It's a lot of weeding through to figure out what do we need for this process. And the industry is still kind of figuring that out. You know, alcohol industry, you've got hundreds of years of operating to figure out this is the spec that we need. The industry figures out that commercial point, this is what it's worth paying because this is what I care about. We're still figuring this out as an industry about where those equilibrium points are. It's all about quality, but at the same time, if we did everything like the nanotech industry or pharmaceutical, it would be a little price competitive and you would be billions of dollars of investment that isn't coming into the industry now. Experience. Really, it's the experience of the people using the product and dialing that in. How do we do this? How do we do it better? What do we care about? It's interesting as people have started to use absorption as a regular process that it's actually taken on its life of its own. And now it's like, okay, this is a base process that we can do. How do we do it different? What do we really care about? And that is a constantly evolving conversation. Influence. I mean, really, at the end of the day, Murphy covered it great. What do we care about? Why do we care about it? Safety. You know, we need to push people towards not just going for the cheapest dollar, what's the easiest, simplest, but what is right and what is also going to meet the demands of the people who, especially as customers become more and more educated at, and then if you want to do the whole thing organic or GMP, then it gets super fun. So all of these are very multifaceted challenges that come with scale, and it takes everybody working on it to really solve those issues. Speaking of partnerships, high precision gas, carbon chemistry, you know, we just started working together and excited to have more avenues for manufacturers to get access to our products. So before I go to questions, we have a giveaway box. So if any information on there, a phone number, email address where we can get in contact with you, we're shipping them out. But we have a few of our top products just to kind of get it into people's hands and play around with it and say, you know, what are the, you know, what if there's contaminants that you're trying to get out, you know, play around with them, see what it does. There's a lot of information out there, a lot of consultants that we can kind of drive to for continued support. I kind of skipped over the first part, which is going to make it so there's not a lot of questions. The early days, how did we get into this? It started off with bentonite powders, acid activated, and the idea was, hey, you know, this could actually help break up pesticides. And as people started playing around, this was in reaction to pesticide rules in California, where a manufacturer would make a lot, fail against the spec, and so now that oil can't go to market. So what do? You just burn it like a CBD crop that has too much THC in it? Or, to Murphy's point, there's a lot that you can do in oil that you can't do in flour. You can't take a finished product that's flour and pull targeted compounds out of it. In oils, you can do that in post-processing. So now as we find, you know, heavy metals, there's more testing that's coming out, regulations constantly changing, and so whatever you care about in contaminants, whether that's physical contaminants that need to be filtered out, lipids, sediment, more difficult compounds to separate, different types of pesticides, heavy metals, which will go through the distillation too. That's where absorption, which is a process of using special media in order to hold back targeted compounds and then let everything else through, is starting to become common practice. And it's used in other industries, not just to pull out certain compounds, but it can also be used as a brunt force and affordable separation step. Where, you know, like we found a lot of people in CBD like to, if they pull out a lot of their chlorophyll, then it makes crystallization downstream a lot more efficient for them. So sometimes using a consumable in process can actually make for a more affordable and more scalable and consistent output of your products. Going back to actually, I'm gonna do it. My question is, what is a compound that somebody here has had to remediate? They have to take out of it. Yeah.
Arsenic.
Arsenic, yeah, heavy metal. Definitely going to be one of the four.
Man, you wonder. You can't
I'm not trying to win.
Just bragging.
Just paying attention.
Yeah, absolutely. No, that's awesome.
Right.
Spiromethamine.
Spiromethamine. Ooh, that's a
Top one.
that's a nasty. That's,
Yeah.
did you get it back?
No.
Well, you do now.
Oh, yeah.
Any other questions? Don't forget we have the giveaway over here. Yes.
So my question does relate to arsenic. So I think as far as the state law on this right now, if you go through the COA process with your flower and you pass hot for arsenic, there's no remediation allowed.
Yep. That's correct.
Unless you do R&D testing.
You can test.
Once you submit for your full compliance panel, the results of that compliance panel have to be reported to OMMA.
Right.
But if you do a R&D pesticide screen, you're not finished with your product yet. You can do whatever you want with it before you submit for your compliance panel.
So this discussion right here, just to blow it up a little bit louder, is actually really cool. It's a snippet in time where you have a law where the state is going, if you show that you have this heavy metal in your biomass, you can't touch it. Yeah, it's garbage. But that is because the state is either unaware or not confident in manufacturers' capability in order to pull that compound out consistently and confidently. And so that's where distributed capabilities of manufacturers are going to have a meaningful impact in the change of the laws. Because if manufacturers know what's going on, know what they can do, and can consistently achieve that output, the rules are going to be written based off of what the industry can do. So this is a great example where the laws are written because of a lack of confidence in the processing step, and that can change with time. So it's allowed in the R&D step, which this is news to me. I'm not familiar with the particular state operating environment, but it's a beacon of there's an openness, like, hey, we can figure this out. And when it becomes standard and normal, that, oh, of course, you test for arsenic, you do that. Then the rules change. Because why would you force people to destroy products that can be fixed? And I think that that's a lot of the message that's important to get out into processors that say, wait 1 second, I don't just take the oil, add solvent, and that's the end product. You can do a lot more than that, and it's really cool to see what people are doing. Definitely, Murphy Murri's.
If it makes you feel better, though, you can't remediate heavy metals in Colorado either. So, like, even established
Is there a
markets-
protocol in any state for it?
What's that?
Is there a protocol in place for any state?
So, right, the problem is that in most cases, the government can't require you to perform a certain process. It's the opposite, where you have to propose a process and get it approved. And so that's asking you to carefully define a repeatable process and write it down, and then prove that it's repeatable and achieve it with labs that have also possibly not proven that they can get repeatable test results on the same heavy metals. And you're submitting that to lawmakers. So it's a hard triangle to make go. You know, it's not a wheel. So there is a process in every state to allow it. For example, like in Colorado, there's only certain solvents we can use. You can submit a proposal to be able to use a different solvent, but if you don't have a lab that can support your proposal with testing, then you won't get very far, and so that puts the burden on you to be analytical in-house. And so it's just what it comes down to is all of us have to care and then pay a lot of money for testing so the testing gets better and stop being babies about it, because science is expensive.
Even for example, your pesticide testing that we can't test in Colorado right
we
now.
don't even test. Yeah,
right?
we don't test the
Because
pesticides in Colorado.
she's ahead of the
Or
game
especially cannabis-specific ones?
Exactly, and she's ahead of the game on pesticide testing, and she tries to send it in, and they send it back to her and say, sorry, not right now. And so it's one of those things where when you try to develop the process and develop the standard, sometimes you still get pushed back, and so you have to go around another way to try
That's
to
why
make stuff
scientists
happen.
are all mad, because it's
Right.
really hard.
Right.
So the discussion, just to kind of widen it to the whole room, is, wait 1 second, even in Colorado, you can't do remediation. And Murphy was saying, well, you have to prove that you have a process and it's repeatable and provide that. The burden, the research burden on an individual operator in order to change the rules is tremendous. But through partnership, right? If people care about this, and then you have third parties, trade associations showing what processes are doing, you can tie all the efforts together and share that information and change these rules. So first off, we have to care that those things are in there. And it is a little scary because it's a fluid industry. We're figuring it out by being wrong a lot. But there's something to be said about coming together, and that's what's really cool to see about an event like this. Let's keep doing it. Awesome. Thanks, everyone.
So just as important as the solvents, as the medias, as the testing and so forth, it's also the hardware as well. And we're pleased to have Caitlin here from Worthington Industries to talk about some of the hardware and some of the products, like the cylinder that comes in.
Hi everybody, thanks so much for having me. It seems like a wonderful group. I've had the opportunity to talk with a lot of you. Worthington Industries is a publicly traded manufacturing company based in Columbus, Ohio. We actually, some of the areas of expertise, our areas of expertise include pressurized cylinder manufacturing, steel processing, material sciences, all the things that are really important to creating a really good pressurized cylinder. And so when I'm talking about these tanks, these are the tanks that sit outside in cages outside of a hydrocarbon extraction, delivering, clean and pure gas to this market. That was something that we wanted to align with. So that was something that we kept in mind moving forward as well as we continue moving forward in this journey. So our current offering, I only have one slide here, so you've seen our current offering up here, but our current offering is basically two different types of cylinders for this market. So it's the carbon steel tank, which you guys probably see most often outside in cages outside of extraction facilities. We also have a stainless steel offering that we pulled together recently as well, and I'll talk a little bit more about that here in a second. Yes, so both of these are available in the high precision gas booth tomorrow, so feel free to come by and check them out. We ship them in, and we would love for you to take a look at them and ask us questions about them when you come by. So a little bit more about the carbon steel cylinder as a starting point. So this cylinder obviously is what you most often see outside of the cage. High Precision's actually taken this cylinder a step further, which has been really cool. So they've asked us to create a more internally clean version of this tank. And how we were able to do that basically is we use pickled steel that's treated with a hydrochloric acid, and then it gets nitrogen purged and sealed prior to leaving the facility. And so that's one of the ways that we ensure that it's really clean when it leaves, our facility. The other thing that we've looked at is stainless steel, and we really feel like stainless steel might be the direction that things are headed, right? Because if you look at precedents in food and pharma and other spaces, stainless steel is really valuable for a few different reasons. So Worthington created this 100-pound stainless steel tank. We think it's the cleanest option leaving our facility right now. The cylinder has an even more in-depth cleaning process, which you can see up there on the side. There's some details there. And one of the great things about stainless is when it's out in the field over a period of time, it's more resistant to oxidation from water and moisture, which ultimately reduces the chances of mineral particulates and corrosion. So obviously you know the benefits of stainless steel. And we just wanted to make sure that we were starting to think a little bit more about clean cylinder design in that way and the materials we're using, which is one of our core competencies at Worthington. So some of our goals for the show, we're, as I mentioned, still somewhat new to the space, and we would really like to learn from you all. We'd like to get a better understanding of how we can continue to evolve these tanks in a way that would best meet your needs. We have some ideas for how to make these even cleaner moving forward from a design standpoint and a cleaning process standpoint. And we would love to just kind of talk with you folks about what you think would be ideal. So if you don't mind just coming by and stopping and talking with us, over the next couple of days, we'd really appreciate it. So thank you so much.
Well, that concludes our education portion of it. So hopefully you guys will stay around, have some fun. There's still some food left, get some good drink. Enjoy yourself. And before you guys go, if you guys are interested in the Oklahoma Cannabis Industry Association, Caitlin over there, why don't you come up here and maybe say a couple of words? They're a great organization helping the legalization, helping pushing the legislation, making sure it works. So,
yeah, I want to thank Mark and Murphy and everyone for coming out here and basically just want to introduce myself. If you don't know who I work for, it's the Oklahoma Cannabis Industry Association. If anybody has any questions or wants to learn more, feel free to come up and ask me, and I'll get you hooked up and squared away. So everybody, remember to tip your bartenders, and have a good night.
I know. I'm terrible. I can't quit my day job. How do I? Seriously?
No, I told him.